Hey, friends, uh, hope you are good. Welcome to Animation Lab. I'm Rahul. Uh, the last we have studied about bag of words. Today we will see into the similar context. Next chapter. Today we are going to discuss about sentiment analysis. One of the natural language processing topic, and it's this topic is very important in the sense we have in today's generation. We have social media, we have market future market analysis, we have feedback systems of the various products, business domains, etc. So this particular today we are going to see a very basic and simple example to learn the sentiment analysis in Python and with Scikit-learn libraries. So let's start with the. So I'm just giving just first of all insight. This code will be available on my GitHub uh, link, and the link will I will provide it here into the video, a YouTube video here in the description section. And here you see I am using one of the dataset, a very simple and good dataset like movie review dataset, which is from NLTK libraries. We can download it here in the code itself. So here we have film reviews. 2000 almost there are 2000 film reviews, and these film reviews are having 2000 records. So let's discuss step by step. We'll import the libraries, uh, SQL libraries. We are going to do model selections. Then we are going to do TF-ID vectorizer, as we had discussed in last video, and how the score happens. We will again see one of the small example here, and for the sentiment analysis, we are going to use the classification model, naive Bayes classification model, multinomial naive Bayes, and we will do predictions on the documents that are the reviews that are present and test it. So here we have downloaded this database. There's a movie review database with the stopwords. And after this, we are going to just do analysis and just check the reviews, positive, negative reviews. We will collect it and we prepare a data frame that will show you the documents and sentiments. That is the labels. We call it a total reviews. And as we are going to do the training, we need data to be shuffled. So we are going to shuffle this data so that we'll get the random values in the test and train set. And this is the data. As we have 1000 records with positive sentiments and 1000 records with negative sentiments. So let's move ahead. We will split the data. First of all, I will not explain all these things, so we will focus on the important topics. So once we get the train and test split data, we will do the feature engineering. Here, uh, our movie reviews database might be having uh, millions, thousands, and millions of the words. Here, for the analysis purpose, we are only taking 2000 words that are most frequent used, so that we can do the sentiment analysis on them. So maximum feature we are doing is 2000. So let's so we are using TF-ID vectorizer. You know how the TF-ID score is calculated. Just in case, like these are the documents I call one review is nothing but a document. A document is having the label 0 or 1. That is 1 for positive sentiment, 0 for negative sentiment. So these are the reviews. And how it will be calculated, it will prepare a vector for each and every word into document, all documents, and it will frequency count for the each document on these words, right? So like in the document 0 we have films adapted. You'll see how in the document 2, like in the document 2 here, for example, you have this one, right? So this is the thing you have here in the document 2. So in document 4, you have general. So this is how the vector is prepared. And on this basis, it will calculate the term frequency and inverse document frequency, that score it will calculate. Once it has calculated this score, uh, we are going to provide that complete document vectors to the training. So we prepare the data on the document vectors. We pass that document training dataset, and we pass the same vectorized, that is document vector, uh, for the testing, and we pass it to the for the training. So this is the training set where we have 1600 reviews, and in the test set we have 400 reviews, right? And we have vocabulary maximum feature that we are fetching out of it is 2000. So let's move ahead with the training and how the model works. So here we are using a sentiment to determine the sentiment. We are using classification, that is a positive or negative. It's a binary label classification. So we are using multinomial binary multinomial naive Bayes algorithm. So we train this data with the vectorized that data. Uh, we have documents, and once we have trained, we'll pass the test data, price data, and we'll get the predicted values, right? So this will give us the sentiment value for the of the prediction. Now these predictions will compare it with the true labels. Okay, so here is the statistics, analytical statistics for the algorithms, how the algorithm has performed. Here we will not discuss this one, but we will see how the confusion matrix is helping. So out of this, for example, there are 50 documents or reviews that the algorithm has predicted negative, but actually those reviews are positive sentiments. And here, if you see 30 reviews are such that those are predicted positive, but those are actually negative. So this is how the confusion matrix helps us to understand how the learning is happening. So in order to visualize and see, we have a lot of features here, but in order to test and see how the learning actually happens, and to see how we can utilize this particular sentiment analysis and on some of the words. So what we are going to do is we will prepare a function which will get me topmost 50 such words that are majorly impacting into the sentence. Okay. So here we have prepared one. We'll pass the vectorizer and model options here, and we are choosing topmost 50, only 50 words. Okay, that's sufficient. You can choose any number like 20, 30, whatever. Here I'm choosing the 50 topmost 50 words that are contributing to a particular sentiments, negative or positive. Okay. So in order to do that, I have to get all the feature names, and then I have to get the probability of that word. So that whether that word has probability with the negative score, that word have a probability with positive score. So once I get that, I will calculate the score difference. Why score difference? Because I am interested in the words that are impacting majorly to the negative sentiment, and I'm interested in those words that are impacting majorly 50 words that are impacting majorly into the positive. Most of them, the words, I'm not interested. I want to clear distinction of those words who has high impact on negative and positive sentiment. So that is why here we are calculating the score difference. So like score difference is like if you have the score difference is like more than one, you have positive score divided by negative score. If the positive score is more than negative score, obviously the ratio is more than 1. And if the positive score is less than uh, negative score, uh, is less than negative score, obviously uh, the friends, let us see here, the features that we are extracting, those will provide the scores, negative scores and positive scores. So we'll find the score difference, and we are extracting only the words, top 50 words who has major score difference, right? So the first 50, like if the score difference list has the first 50 at very less uh, uh, with very less probability. So this probability, the ratio, and the last 50 elements will be having the highest ratio of the positive and negative scores. So we are going to sort these indices on the basis of the positive and negative score difference. So once we get the top most 50 all words that are majorly impacting the negative and positive sentiments. So this is the function we have, and we are calling here the function with we are passing vectorizer and model and the topmost, those extracted topmost 50 words. Once we do that, just for helping, these are, if you plot the bar chart here, you will see the leftmost chart. These are the list of 50 words that are impacting to the negative, major impact into the negative sentiments, right? So for, if you see, there is horrible, there is a crap, there is like funny, badly, right? So in the right side, there is positive sentiments. If you see, there are words like wonderfuling, right? Excellent. So these are the words that are majorly contributing to the positive sentiments. Now, if you go ahead, so once we get this top 50 words for negative and positive sentiment, we'll go ahead and test the model. So our model is like predict sentiments. We have text, vectorizer, and model. So we'll get a completely new review of the movie. For example, we are going to test three examples. So we are going to test is if we know that the review is positive, and we'll check the probability of the positive sentiment. If we know if the message or the review is negative, we'll check the probability of the sentiment with respect to positive probability, and mixed sentiment, we will have one input with no that has mixed sentiments for the movie review. So here we get the new input, we pass it to the vectorizer, and once the vectorizer is complete, we do the training on the vectorized data, and once we have training, we will do the predictions. So it will give us a prediction with a classification with positive or negative. So the sentiment label, if the prediction is equals to 1, then it is positive, and if the prediction is not 1, then it is negative. So uh, if you see, we have a first example. This movie is absolutely brilliant. So if you see, if we run this, and if you see, if you run this, these are the examples. So review by user, this is the review by user, and we have got the predicted sentiment as positive, and the probability for that particular sentiment is positive probability is 0.72. Now, if you see the next example, the plot was total mess like. So this is the next review. We are testing with the new input, and we see the sentiment is negative, and the positive probability is for the 0.19, right? And for the mixed probability, we got 0.44, so which is around 0.5. So this is how we get the new input to new review, a sample input, one sample review input, and we will test out uh, sentiment analysis model. So I hope this is very simple and very basic example. You will try with your own data set, try with your own model of doing classification. And if you find anything with good feedback or whatever, if you face any difficulties, so please write in the comment box, comment section, and discuss with me. I will respond to your queries necessary. Okay, so if you like this video and if it is helpful, please subscribe to my channel, Anishul Labs. Thank you, friends. Thank you. Bye.